Module 2, Introduction to vSphere and the Software-Defined Data Center. As a vSphere administrator, you need to be familiar with several of the components on which vSphere is based upon. You should be able to have the following concepts and the best practices by the end of this lesson. Virtualization. What is virtualization? ESXi. What is ESXi? And a virtual machine. You should have the fundamental vSphere components and use of vSphere in the software-defined data center. And you should know or be familiar with the use of vSphere clients in which you administer and manage your vSphere environments. There are 4 lessons in this module. In this lesson, we're going to basically give you an overview of vSphere and what the software-defined data center is. By the end of this lesson, you will be able to meet the following objectives. You'll know how physical and virtual machines are similar and how they are different. You'll be able to describe the benefits of using a virtual machine or virtual machines. You'll also be able to describe how vSphere fits into the software-defined data center and within the cloud infrastructure. In traditional architecture, there's a lot of things to consider. And highlighted in this slide, first thing is you have a poor use of physical resources. So basically what that's saying is all the physical resources are just pertained basically to that machine, the application, the operating system, the network, the storage built within it, and basically it's all in one shop. You got high management and maintenance costs involved in it. That comes along with, say your storage or your hard drive dies. Well, you've got to take that hard drive, physically replace it in the traditional architecture. Same thing with your network card. This dies, you have to take it out, physically replace it in that physical computer, physical machine. So that relates to high physical infrastructure cost. Provisioning challenges. And you get insufficient failover and poor disaster recovery. If we're using all this, so this is one PC, and we're going to name this PC1 for instance. If this is the PC on here, and our hard drive dies right here, and you don't have your data stored anywhere else, that becomes poor disaster protection, in my opinion. And basically what that's saying is, once this dies right here, you've lost all your data. So where's it going to go? Well, let's hit the next slide and talk about virtual architecture. Virtual architecture has a lot of benefits. You can expand the use of the physical resources. So basically we can have a large server sitting out here to the side, which you see right here, server 1. You got your network card and you got your storage device, all built in this server here. Well, with that being said, you got a hypervisor, which that is VMware here. Then you have different VMs. So we'll name this one 1, 2, 3, 4, 5, 6. So you got 6 VMs, and they're all using the same components here to make it run. So with that being said, that's where you get your expanded use of your physical resources. You have reduced management and maintenance cost. And where you get that is by you having reduced management and maintenance costs. Well, if you've got 6 people using 6 virtual machines here, then you got it all mitigated to this one server, one network, one storage device, all built in to run all 6 of those virtual machines. You can improve your desktop manageability and security here, which I think is a big one in today's time. We're all concerned about security. How can we manage things easier? How can we cut costs? Well, here you go. VMware gives you the option for more manageability and security. You can build all your security in here, and I like to bring up NSX. Basically what NSX does is wraps a firewall around the VM and each individual VM. We'll go into detail maybe a little bit later on in that and optimize and scale. How to, a little bit more security. You have increased availability of applications. Well, being all this now is wrapped up into one virtual machine, basically what happens is every VM 1, 2, 3, 4, 5, and 6 can share all of those applications within that virtual environment here. Then you got the operational flexibility. You got a lot of flexibility here. You can add machines, but just remember, you can only add as much as storage as you have. You can only give it as much as this main physical hardware will allow you to virtualize to get machines. So what is a virtual machine? A virtual machine is basically a software representation of a physical machine and all of the components it takes to make a virtual machine. And what that does, it takes the physical machine, which is a regular PC or your laptop that you use every day, and it converts it and basically into files. So here's your virtual machine here, and we'll name this VM1. Okay, and with that being said, what it does, you have all this built in now. So these virtual machine components, which are basically files, you have the operating system, which that could be Microsoft, it could be Linux, yeah. You have VMware tools installed. You got your virtual resources. You have your CPU, your memory. You got your network adapters. You have your disk and controllers for storage. Your parallel and serial ports are all built into that. So what is an advantage? They can provide basically an instructional set of architecture as the actual computer. And when you create a virtual machine, you create a virtual disk, so everything on that machine can crash, but if it does, it doesn't affect the host machine where all the physical resources are being stored. Like on server 1 here, well, on this server, say that's actually controlling 2 VMs here. Well, VM1 and VM2, if you lose your resources here, it's not going to affect it on the server 1. That's where you come in, you got manageability with that. The next thing there are also security benefits to running virtual machines. And some of that, if you need to run an application, you can then run it on the guest operating system. So basically, if the application were to cause damage on this VM right here, then you know, oh, okay, well, let's convert over to VM2 and try a different version of the software here and set VM1 back up, or the opposite. We can have the correct software running on VM2 and do all the testing on VM1, and we never lose downtime. So once again, let's go over the benefits of a virtual machine. Some of the benefits are they're easy to move or copy. It's all encapsulated into files, which are those components, and they're independent of your physical hardware and easier to manage. They're isolated from other virtual machines running on the same physical hardware, and they're insulated from the physical hardware changes. Now, if we go back to physical machines, when we just saw virtual machines are easy to move and copy, physical machines are not easy to move and copy. They're bound to a specific set of hardware components, meaning your network device or your network card is separate. Your storage, which is your hard drive, is separate. So with that being said, if that fails, then you've got to replace the network device in this physical PC here onto the virtual machine. If that virtual network adapter fails, you'll be able to go in and add a new virtual network adapter. Storage, same thing. You got your virtual storage sitting out there, therefore you can control the storage all in here and you never really lose any downtime. So what are the types of virtualization? Virtualization basically is a process of creating software-based representation of a physical device. And as we've been discussing, we've spoke on a server, desktop, the network, and the storage device. Virtualization is the single most effective way to reduce your IT expenses while boosting efficiency and the agility for all size businesses. So you're ranging from small to large corporate enterprise businesses here, and this is what virtualization does. So let's talk about server virtualization. Server virtualization, what it does, it addresses the inefficiencies by allowing multiple operating systems to run on a single physical server as virtual machines, each with access to the underlying server's computing resources. Let's switch right here. So when we say underlying to the computer resources, okay, so we have our server here. Let's say we have a 1 terabyte drive on this server. And we'll name this server 1. On this server, we have VM1, VM2, VM3, and VM4 connected to it. Now what I'm going to do is I'm going to use the storage just as a reference here to let you see how the server virtualization basically works, and we're going to use the storage device as it. So this is 1 terabyte drive. So with that being said, we could give VM1 250 gigabytes. We could give VM2 250 gig. We can give VM3 200 gig. And VM4 200 gig. So with that being said, that's 900 gig that we're using here. If we take it and we add 2 more virtual machines, let's say VM5 and VM6, and we give VM5 75 gigs. Just remember, each VM you add, it subtracts from that total of the 1 terabyte max space that you have. So now instead of using 900 gig, using 975, and say you try to go to VM6 right here, and you try to allow it 100 gigabyte, will not work, because now you're over your 1 terabyte limit by 75 gig. And then we don't recommend even maxing it out, because what you're going to do right there, if you give this one 25 gig right here on the VM6, you're going to be at your 1 terabyte capacity. It's not really efficient and not really a correct way to do it. You want to leave a little bit for growth, just in case you got machines. So what I would do is take VM1, if you're not using all 250 gig and you only use 100, only give it 100. VM2, same thing, give it 100. Well, if you notice VM3 needed 300 gig, give VM3 300. But that's just a prime example of what server virtualization is, which we just discussed right here. Network virtualization. Network virtualization is basically when you reproduce the physical network in a software manner. And what that does is the applications run on the virtual networks exactly as it would on the physical network. Let's go back right here. Let's start over. So we have our physical machine here, and I'll just use PM for physical machine. We have VM1, VM2, and let's just do VM3 here. We have our hypervisor here. Actually, that runs everything. And then we have our physical components under here, which are going to be shared amongst all of these VMs here, as you see right here. So, on a physical device, we have our network card sitting right here. Here's our little physical network card. If that network card dies, that physical machine right there is done. On the hypervisor right here, what's happening with network virtualization is, we're taking this network device built in right here, and this right here, in the physical component side. We are virtualizing it up here to share amongst VM1, VM2, and VM3. So basically VM1 has its own NIC, VM2, and VM3. So we just talked about network virtualization. Storage virtualization. Storage virtualization is a process of creating a software-based representation of network storage devices that appears to be a single unit. Okay? So, if we have our storage on just say a laptop, we got a 500 gig hard drive. That is the only machine that can use that 500 gig is that laptop right there. Okay? So, let's talk about the shared storage. We got a big pool of storage here. And with that being said, we can share this shared storage with VM1, VM2, VM3. So what we're doing here, we're taking all of this here, we're basically sharing it to VM1, VM2, and VM3. So we're sharing, virtualizing that storage, and we're sharing it amongst 3 virtual machines instead of having it singled out to one device here. So we just talked a little bit about server virtualization. So what is desktop virtualization? Desktop virtualization basically enables you to respond more quickly to changing needs within your organization. And a great example of desktop virtualization is something we discussed prior back, just a couple minutes ago. So if I wanted to take and deploy a desktop real quick, I want to be a Windows 10 machine. I can say, okay, I want to do some testing on this machine here and see how it acts. In the process, I'm going to spin up another VM and I'm going to test a different software on this machine. Well, if you notice it's not working correctly on the first virtual machine you had it on the second machine, make your adjustments and see the differences, see what's not working, see what's working. If it's not compatible with physical hardware that you have on the underlying infrastructure, then look at the other VM that's got the other set of software running that you need. See if it is compatible. Work through it. That's a major advantage by having desktop virtualization. So what is the software-defined data center? A software-defined data center is basically all infrastructure that is virtualized, and the control of the data center is entirely automated by software. So as you see right here in this slide, everything you see here is controlled by software. And just know that vSphere is the foundation VMware vSphere, is the foundation of the software-defined data center. So let's draw this out a little bit better, or make a little bit more sense. Okay. So, in the software-defined data center, you got your service management. All right. Your service management basically is used to track and analyze the operation of multiple data sources within your software-defined data center, or the SDDC, as some people call it. And what you want to do is you want to deploy vRealize Operations Manager and vRealize Login Site, maybe across multiple nodes, and what that does is allows you to have continued availability and increased log rates so you can see what's going on within the SDDC. All right. Now you have your cloud layer, you have cloud operations, or your cloud management layer. So you got your cloud operations here. Your cloud management layer, the cloud operations layer, it includes the service catalog. It houses the facilities to be deployed, the orchestration, and then provides the workflows to deploy the catalog items within a self-service portal. And what this does, it allows, or that self-service portal, it allows end users then to use the SDDC, which is right here, because your cloud operations, you have all this that you could use, but it allows you to use all the SDDC operations. So as you notice right here, so we go from our cloud operations to our cloud automation, our policy-based management and automation. Then we get to the virtualized infrastructure. This layer establishes a very complex virtualized environments in which all the other solutions integrate. And when we say by integrate, we integrate our server virtualization to our virtual networking, to our software-defined storage, and back to virtual server. So what this does is it takes and it lets it all be used within virtual infrastructure. So as you see, you have your server virtualization, your network virtualization, and your software-defined virtualization. If you split this down the middle, having your SDDC, you could then have your own hybrid cloud, your private cloud, your public cloud. Your public cloud would be Azure, Amazon Web Services, Google. Your public cloud, basically VMware, OpenStack, or your hybrid cloud, vCloud Air, and any kind of other networks, service provider partners that are supported. vSphere and cloud computing. So what is basically vSphere and cloud computing? vSphere and cloud computing is defined by the NIST standards and is a ubiquitous model for cloud computing. It's convenient and on-demand network access to a shared pool of computing resources. Okay, so let's draw this out. I got a different way I'm going to draw this out for you. May make a little bit more sense. So let's take right here and look at cloud computing. All right, so we're going to draw out VM1 here. You have VM2 and you have VM3. Under those VMs, we now have a whole separate layer right here. And within that separate layer, we have our VMware Cloud Foundation. Okay. So we have our cloud foundation set up here. And the cloud foundation, what it does, it provides an integrated cloud infrastructure, which basically houses your compute power, which would be your servers, compute, it houses your storage, and it houses your network. And we'll draw some little dots here going out. So as you see here, we got our network where it goes out, we have our storage, and we have our compute power. Now the cloud foundation, to know once you have all this in the cloud foundation of your compute, storage, and your network, it's important to know that this extends the hypervisor, or extends the vSphere Core hypervisor with integrated defined storage, which we have here. It defines your storage, your networking, and we also have another layer of security that it provides. And not only on top of the security, we have a layer of your cloud providers, such as, if we go down here, we have your private cloud. And then we could have your public cloud. So some of the use cases here would be exploit high availability, performance, and scalability of your SDDC, basically to run mission critical applications, and that may include databases, web apps, VDI. You can automate your IT with this. And the hybrid cloud, which you're seeing here, is basically vSphere and cloud computing hybrid, is basically you're able to then build a true hybrid cloud with common infrastructure and within a consistent operational model, while connecting your on-premise and off-premise data center that is compatible and distributed throughout your entire organization. You should now be able to meet the following objectives. You should be able to understand how physical and virtual machines are similar and how they are different. Describe the benefits of using virtual machines, and describe how vSphere fits into the software-defined data center and the cloud infrastructure.